Alright, velkommen tilbage. Afsnit 5, kapitel 6. Enums and pattern matching. In this chapter, we'll look at enumerations, also referred to as enums. Enums allow you to define a type by enumerating its possible variants. First, we'll define and use an enum to show how an enum can encode meaning along with data. Next, we'll explore a particularly useful enum called option, which expresses that a value can be either something or nothing. Alright? Then we'll look at how pattern matching in the match expression makes it easier to run different code for different values of an enum. Finally, we'll cover how the if-let construct is another convenient and concise idiom available to handle enums in your code. Alright, enums med match og if-let. Interessant. Alright. Så lad os lave en cargo new. Lad os kalde den for enums and pattern matching. Alright, great. Alright. Where structs give you a way of grouping together related fields and data, enums give you a way of saying a value is one of possible values. Alright. Okay. Så IP-adresse kan enten være v4 eller v6. Det kan du repræsentere ved hjælp af den her enum, der hedder IP address kind. Igen start Rust analyzeren. Cool. We can create instances of each of the two variants, kind of like that. Okay, double colon. Auto completion. Beautiful. Note that the variants of the enum are namespaced under its identifier, and we use double colon. This is useful because now both values are of the same type, IP address kind. You can then, for instance, define a function that takes any IP address kind, and we can call this function with either variant. No, the route 4. thinking more about our IP address type. At the moment, we don't have a way to store the actual IP address data. We don't know what kind of it is. Det kan man så gøre her. Du kan en kind, og så giver du en adresse. Here we have defined a structured IP address. Okay, ja. Vi har en kind. Du definerer med en enum. Rather than an enum inside a struct, we can put data directly into each enum variant. Okay, this new definition of the IP address enum says that both v4 and v6 variants will have associated string values. Okay. We attach data to each variant of the enum directly, so there's no need for an extra struct. Here it's also easier to see another detail of how enums work. The name of each enum variant that we define also becomes a function that constructs an instance of an enum. That is, IP address v4 is a function call that takes a string argument and returns an instance of the IP address type. What the hell? Okay. Hvordan var det, jeg debugger ting? Right, debug. Hvordan var det nu? Kolon, spørgsmålstegn. Okay. Se, hvad sker. Ikke det store, men fair nok. One. Alright. We have shown several different ways to define data structures to store version 4 and version 6. And it turns out wanting to store IP addresses and code which kind are so common that the standard library has a definition in use. Okay, let's have a look at how the standard library defines IP address. It has the exact enum invariants that we have used, defined and used, but it embeds the address data inside the variants in the form of two different structs, which are defined differently for each variant. This code illustrates that you can put any kind of data inside an enum variant. Okay. You can even include another enum. What? Alright, det er ret sygt. Okay. Okay, jamen åbenbart er enums så ikke særlig konstante. Hvis deres værdi først bliver defineret senere. Altså her bliver den så defineret ved the runtime. Loop back. Alright, defining en enum som sådan her er ens med at similar to defining different kinds of struct definitions, except the enum doesn't use the struct keyword and all the variants are grouped together under the message type. Okay. What? We are also able to define methods and enums. What the hell? Crazy. Okay, så enums er ret powerful i Rust. Det er lige noget, man skal vende sig til. Option enum and its advantages over null values. This section explores a case study of option, which is another enum defined by the standard library. And the option type encodes a very common scenario in which a value could be something or it could be nothing. For example, you request the first item in a non-empty list, you would get a value. Men hvis listen den er tom, så vil du ikke få noget. Hvordan expresser vi det? Programming language design is often thought in terms of which features you include, but the features you exclude are important too. Rust doesn't have the null feature that many other languages have. Null is a value that means there's no value there. In the languages with null, variables can always be in one of two states, null or not null. Null references The $1 billion mistake. The inventor of null. I called my $1 billion mistake. At that time, I was designing the first comprehensive type system for references in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler, but I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, and system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. Problemet med null-værdier er at prøve at bruge dem som en null-værdi, får du en error. Because this null and not null property is pervasive, it's extremely easy to make this kind of error. However, the concept of that null is trying to express is still a useful one. Null is a value that is currently invalid, absent for some reason. Okay, så Rust har ikke null, men den har en enum, der enkoder den her concept af, at værdi kan være der eller ej. Så det hedder option. Okay, det er sådan noget. Det er en enum. Den hedder option. Den har en generic. Den har værdierne none eller sum, som er en funktion. Den har sum. En generic. I guess, der tager imod t. Det er t-genericen. Rust requires to annotate the overall option type. The compiler can infer the type that the corresponding sum variant will hold by looking at a non-value. Okay. Kan jeg bare bruge den her? Nu gør jeg noget. Åbenbart. Some value of type T. Some number. And set. Unwrap. When we have some value, we know that a value is present, a value is held. Alright. What do we have? In short, because option T and T, where T can be any type, are different types, the compiler won't let us use an option T value as if it were definitely a valid value. Alright. Ooh. You have to convert an option T to a T before you can perform it. Before you can perform operations on it. When you use that value, you are required to explicitly handle the case when the value is null. If you're aware that a value has a type that isn't an option T, you can safely assume that the value is null. This was a deliberate design decision for Rust to limit null's pervasiveness and increase the safety of Rust code. Så how do you do that? Hvordan får man den ud? In order to use an option value, you want to have code that will handle each variant. And you want some code that will run only when you have some T value. And this code is allowed to use the inner T. Right, the match expression is control flow that does just this when used with enums. It will run different code depending on which variant of the enum it has. And that value can use the data inside the matching value. Cool. Rust has an extremely powerful control flow construct called match that allows you to compare value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. Okay. Match den her med den her. En penny. Alright. Alright, next up, pattern match arms. An arm is two parts, a pattern and some code. Så det her, det er dens arm. Ja, det er dens pattern. Det er så, I guess, den kode. When the match expression executes, it compares the resultant value against pattern of each arm in order. Okay, the code associated with each arm is an expression, and the resultant value of the expression in the matching arm is the value that gets returned for the entire match expression. We don't typically use curly brackets if the match arm is short. Som i 6.3. If you want to run multiple lines of code in a match arm, you must use curly bracket, and the comma following the arm is then optional. Optional, okay. Også noget, den ikke strictly enforcer af en eller anden grund. Okay. Alright. Another useful feature of match arms is that they can bind to the parts of the values that match the pattern. This is how we extract values out of enum variants. Okay, some example. Switching one of our enum variants to hold data inside it. Okay. Oh. Send. What? Er det lige meget? Hvor forsvandt den? What? Then a value as a US date, right? Beautiful. Okay. Det må jeg sikkert ikke. Because of return time. Wait. Send. Matching with this Matching with option C. Sige, at vi vil skrive en funktion, der tager en option med en signed integer 32. Og hvis der er en værdi i den, læg 1 plus 1 til den værdi. Ellers return none and not attempt to perform any operations. Plus 1. Main. Okay, men den returnerer så også en option. Some eller none. Set. Okay, matches are exhaustive. Okay, the arms pattern must cover all possibilities. Right, exhaustive. Der er en saying i konsulentverdenen, at når du laver et framework, skal det være mutually exclusive og collectively exhaustive. Let me see. Det er et... jeg ved faktisk ikke, om det er et McKinsey-begreb. Jo, det er det. Ja. Så hvis jeg har nogle ambitioner om at ende der i McKinsey, that is, så bør I lære det her begreb. Det er også lidt en meme, så det er jo altid. Det er også noget. Alright. We didn't handle the none case. Okay, så det er det. Så det skal være exhaustive. Cool. Så det vil sige, at vi skal dække alle de possible værdier. Catch all and the underscore placeholder. Using enums, we can take special actions for a few particular values, but for some other values, we take one default action. Okay. Other. Other. Er det en ting? Kan jeg bare kaste den bane, jeg vil. Okay, så det er ikke reserveret keyword, det er bare... alt andet. Det skulle da lidt mærkeligt, ikke? Jeg føler, det er. Okay. Nå, men variabler kan ikke starte med med tal åbenbart. Interessant. Så du siger, at yep, I guess det er fint. Det er bare et catch all. The call compiles because the last pattern will match all values not specifically listed. This catch-all pattern meets the requirements that match must be exhaustive. Note that we have to put the catch-all arm last because the patterns are evaluated in order. If we put the catch-all arms earlier, the other arms would never run. So Rust will warn us if we add arms after a catch-all. Og Rust har også en anden pattern, som man kan bruge, hvis vi ikke vil bruge en værdi, og det er et underscore. Det er et specielt pattern, som matcher alle værdier, men ikke binder. Så I guess det er det samme. Zero. Yeah, we can express that by using the unit type. Ja, så hvis vi ikke vil have, at det skal ske noget hovedet, så gør vi sådan her. Så sker der ingenting. Cool. The if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. Consider the program 66. Så den matcher, hvis der er noget, ellers så ingenting. If value is sum, we print out the value. We don't want to do anything with the non-value. Satisfy the match expression, we have to add that. After processing just one variant, which is annoying. Boilerplate code to add. Okay. Okay, så der er også noget, der hedder en if-let. Sådan her ud. Se her. Så lad den her være den her er. Der hed. Okay. Max. Okay. Max er, hvad vi kalder den her. Hvad som helst. If let means less typing, less indentation, and less boilerplate code. However, you lose exhaustive checking that match enforces. Choosing between match and if let depends on what you're doing in your particular situation and whether gaining conciseness is an appropriate trade-off for losing exhaustive checking. In other words, you can think of is let syntax sugar for a match that runs code when the value matches one pattern and then ignores all other values. We can include an else with an if let. Okay. Count one. Eller vi kan lave en if let her, så if det her, ellers altså den her Jeg føler lidt det her, det er at skyde sig selv lidt over foden. Fordi hvis jeg ændrer på den coin værdi, eller den her coin enum, I guess, de gør det samme. Det var bare mere, hvis jeg ændrede den her coin, jamen så skal jeg også ændre det her match statement, ellers så bliver det bare ramt af catch all, men det er det samme hernede. Så der er ikke nogen forskel. Der er ikke nogen forskel i forhold til maintainability. Jeg tror sgu det er det samme. Alright, we have now covered how to use enums to create custom types. We've shown how the standard library option helps you to use the type system to prevent errors. When enum values have data inside them, you can use match or if let. Your Rust program can now express concept in your domain using structs and enums. Creating custom types to your API ensures type safety. The compiler will make certain your functions only get values of the type each function expects. In order to provide a well-organized API to your user, it's straightforward to use and only expose exactly what you need. Let's now turn to Rust's modules. Alright, det var kapitel 6. Modulerne er jeg ikke sikker på, at jeg vil cover. Det må jeg lige finde ud af. Jeg tænker bare, at det er måske lidt for meta. Ja, lidt for meget meta-programmering. Ja, alright, we'll see. Cool. Tak for denne gang. Vi ser. Hey.